Geo-Surface Quick Start, Guide Part 8, How to Identify the Optimum Route to Drain a Problem Area. Sometimes it's not possible to follow the flow lines to drain a problem area. In this demonstration, we'll identify the most viable alternative option to drain this depression area to the watercourse outlet to the west. As we can see, once we add the HD elevation and flow mapping layers, the depression is surrounded by ridges, and the natural drainage route is to the northeast. However, what if we can't or don't want to drain towards the northeast? Perhaps this would mean draining onto a neighbor, or maybe we'd just be creating more problems in a different area of the field. By examining the flow mapping, we can see that there are three possible options that might allow us to drain this area to the watercourse. The question is, are any of them viable? And if so, which would be the most efficient option? By drawing virtual survey routes for all three options, we'll be able to compare them and determine which, if any, are the most viable. Using the HD elevation overlay combined with the flow mapping, you can identify the paths of least resistance that should result in the shallowest cuts through the ridges. As always, make a habit of starting your virtual survey drawings at the outlet end and then draw uphill to the inlet. Add a best fit grade line to each of the proposed routes and add some depth guides if you like, so you can see how deep of a cut might be required to get through the ridges. In some cases like this one, you may even find that the inlet elevation is lower than the outlet. In this case, use the reverse outlet option to force the best fit grade to set the lowest elevation as the inlet and require deepening at the outlet to accommodate the run. In this example, the option to the southeast would result in a very deep cut through the ridge of approximately 60 inches, and we'd be moving just over 315 cubic yards of dirt to make it work. The middle option is a little better, with a 40-inch maximum cut depth and an estimated 200 cubic yards of dirt versus the 315 yards of the previous route. But by far the best option in this case would be the route to the west, which would require a maximum cut depth of around 20 inches and only requires 76 cubic yards of dirt to be moved. So here we have demonstrated a great example of the true value of being able to use LiDAR data along with Geo-Surface Designer. Without needing to set foot in the field or collect any data, we have identified the optimum drain route for our problem area. While we'll still have to dig a little deep for a short distance, we can go to the field knowing what to expect and avoiding any nasty surprises we may have encountered if we were heading there blindly and planning to eyeball it.